I want to determine the critical points for y equals x squared minus 6x plus 7. First, I need to take the derivative, which will be 2x minus 6, and then set that equal to 0. So 2x will be 6, and x is 3. So my critical point will be at x equals 3. Next, I have f of x equals 6x squared minus x cubed. I'm going to take the derivative, and I'm going to get 12x minus 3x squared. I'm going to set this equal to 0. And here, I want to factor out the common factor. So in this case, it's going to be 3x. And that's going to give me 4 minus x in the parentheses. We're going to set each factor equal to 0. We get that x is 0 and x is 4. Those will be my critical points. Okay. Next one, f of x is equal to x times 4 minus x cubed. So when I take the derivative of this, I'm going to have to use the product rule. So I'm going to be taking the derivative of x, which is 1, times 4 minus x cubed, plus I need to take the derivative of 4 minus x cubed, which I'm going to use a chain rule. I'm going to bring down the exponent, keep the inside the same, subtract 1 in the exponent, and then multiply by the derivative of the inside. And then I'm going to multiply it by x. So let's simplify this a little bit. We have 4 minus x cubed, and now this is 3 times negative 1 times x. I'm going to leave that as negative 3x, and then times 4 minus x squared. They both have a factor of 4 minus x. So you always take out the smaller of the two exponents, and that's going to be 2. So inside, I'm going to be left with 4 minus x, and then minus 3x, which can be simplified to 4 minus x squared and 4 minus 4x. And now we're going to set this equal to 0 to solve for x. I can also pull out a 4 from here if I wanted to. It doesn't really matter, so I'm just going to skip that step. But for now, we're going to set each factor equal to 0. So 4 minus x squared is 0. Take the square root of both sides. I get 4 minus x is 0. So x is 4. And here I can add 4x over to get x is equal to 1. So my two critical points will be x equals 1 and x equals 4. Let's let g of x equal x minus 1 squared times x minus 3 squared. So I want to find the critical points for this. This one is, the derivative is going to be a little complicated because we're going to have to do the product rule and the chain rule. So taking the derivative of x minus 1 squared, so that's going to be 2 times x minus 1. And then we're going to multiply it by g, which will be x minus 3 quantity squared, plus, now the derivative of x minus 3 squared will just be 2 times x minus 3, and then multiply that by f, the first function, which is x minus 1 squared. Okay, so eventually we want to set this equal to 0, but first let's simplify this, because this looks kind of messy. So the question is, what factors do both of these terms have in common? Well, clearly they have a factor of 2. So let's pull that out. you have x minus 1 and x minus 1 squared. You always pull the 1, the smaller exponent. And then x minus 3 squared, x minus 3. We're going to pull out the x minus 3. And now what's left will be x minus 3 plus x minus 1. Okay, simplifying this further, I have x plus x is 2x. Negative 3 plus negative 1 is negative 4. And we're going to set this equal to 0. Each one of these factors is going to be set equal to 0. I can ignore the 2, and if you really want, you could just divide it to the other side. So that's gone. X minus 1 is 0. X minus 3 is 0. And 2x minus 4 is 0. So I get x equals 1, x equals 3, 2x equals 4, so x equals 2. So I get 3 critical points, which will be at x equals 1, 3, and 2. Okay. Now we're going to be looking at functions where the domain is not all real numbers. So let's say if we have y equals x squared plus 2x. Here, keep in mind, x cannot equal 0. Okay, because otherwise we'll be dividing by 0, and we can't have that. So we'll be taking the derivative of this thing. We'll get 2x, and then minus 2 over x squared. So if you want, you can think of 2 over x as 2x to the negative first power, and the derivative will be negative 2 times x to the negative second, which is negative 2 over x squared. All right, so this looks good. Now I'm going to set this equal to 0. And the question is, how do we solve for x? So it's good habit to get this under the same denominator. So the 2x minus 2 over x squared. So the common denominator is going to be x squared. So that means I better multiply the first term by x squared over x squared. And now the 2x times x squared will be 2x cubed. And the second fraction will be negative 2x. I'm sorry, negative 2. Okay. So we didn't have to change anything in the second fraction. Set that equal to 0. Okay, I can factor out the 2 from the top. You got x cubed minus 1 over x squared equals 0. So for critical points, it's not only when my derivative is equal to 0. It's also when the derivative is undefined. Okay, so the derivative is undefined at x equals 0. So we have to consider this as a critical point. And now we want to solve for when it's 0. So we're going to multiply both sides by x squared. And we can also divide it by 2, actually. So let's just do x squared over 2. So those will cancel. So we'll be left with x cubed minus 1 equals 0. I'm going to add 1 to the other side to get x equals 1. So the derivative is equal to 0 at x equals 1. So those are our two candidates for the critical points. But in the beginning we said x cannot equal 0. So 0 is not part of the domain for y. That means we must eliminate it. We cannot use this. So x equals 1 is going to be my critical point. Let's look at a similar problem. What if I have f of x equals x squared over x minus 2? I want to take the derivative. So for this one, I'm going to use the quotient rule. So the derivative of the top times the bottom minus the derivative of the bottom times the top over the bottom squared. Okay, so now we can do some simplifying. I'm going to distribute out the 2x. So I get 2x squared minus 4x. And then I'm going to subtract that with x squared. So 2x squared minus x squared is x squared. And then we have minus 4x over x minus 2 squared. I'm going to factor out an x from the top. And be left with x times x minus 4 over x minus 2 squared. Finally, I'm happy with this form. Let's set it equal to 0. Okay, so we're going to consider two cases. When is f prime equal to 0 and f prime undefined? Clearly, we're going to set the denominator equal to 0, and that's undefined. So f prime is undefined when x equals 2. So we can multiply both sides by x minus 2 squared, so we'll move it over. And that's going to give us x times x minus 4 equals 0. Setting both factors equal to 0, we see that we get x is 0 and 4. Last thing, you always want to make sure that your numbers, your critical points that you found, are part of the domain. So our 0, 4, and 2 part of the domain of this function. So you always have to go back to the original function, f of x, and notice here x cannot equal 2. So we must eliminate x equals 2 and say that our critical points will be 0 and 4.